Okay, Assalamualaikum. Today we proceed with the next topic, which is the classification with two multivariate normal population. Sorry suara saya hari ni kurang jelas sikit sebab saya sakit tekak. So hopefully all of you boleh dengar. Okay. So, from the previous lesson, you have learned the definition of the classification and also the discrimination. And also, we have done how to classify the new observation into the first region or the second region, which is we can know whether that the new observation, the newcomers, will go to which groups, using the region. So today we proceed with the classification juga with two multivariate normal population. So actually for this topic there are dua condition, whether the covariance is equal or the covariance is not equal. As you know, if we have two population, dia punya PDF, we have F1X and F2X for multivariate normal density. So means that we have untuk normal population, we will have the mean vector dan juga covariance matrix big sigma. If the covariance is equal, but usually untuk discriminant analysis, kita akan assume the covariance is equal actually. So we will use this formula to allocate the x0 kat sini, which is the new observation. So kita akan gunakan the ECM rule. Kita akan gunakan classification rule. So the formula is x1 bar minus x2 bar transpose here. Now allocate the newcomers, go to whether it is for the first group ataupun the second groups. So if x0, we allocate x0 to pi 1, which is the first group, if x1 bar minus x2 bar transpose multiply S pool. We have the formula for S pool macam sebelum ni, multiply dengan matrix of x0. So x1 bar ni adalah vector, betul tak? P by 1 matrix. x2 bar pun sama, P by 1 matrix ataupun vector. So you minus that two to find the difference, dan juga last kali you akan dapat vector juga P by 1 dan transposekan dia, you akan dapat 1 by P. S pool adalah P by P matrix, x0 adalah vector juga, you akan ada vector. Tengoklah how many variable that involve, P by 1. Minus dengan 1/2 multiply x1 bar minus x2 bar transpose multiply x inverse, x pool inverse multiply x1 bar plus x2 bar. If this part more than or equal to ln of, find the misclassified ratio, which is the C1 given 2 divide C2 given 1. You know how what is this mean from the previous lesson. Multiply dengan dia punya prior probability P2 divide dengan P1. If this part is more than the ln of the misclassified cost ratio, multiply dia punya prior probability ratio. Kalau more than or equal, so kita allocate the newcomers tadi to pi 1. If x0, if this part less than this part, so we allocate x0 to pi 2. Dia punya otherwise lah. Kalau this part tadi, okay, more than or equal to the value of ln here, okay, kita allocate x0 to pi 1. If this part yang you kira tadi tu less than the value of ln here, so we allocate x0 to pi 2. It's simple. Okay, ini dipanggil allocation rule that will minimize the ECM. So we will use this formula if the covariance is equal. But usually untuk kita proceed dengan linear discriminant, okay, discriminant analysis, we assume that the covariance is equal. Okay, alright. So ataupun kita boleh buat yang macam ni. Another formula. Kadang-kadang dalam your textbook pun ada dia gunakan notation untuk y0 dan juga mu hat. Y0 hat dan mu hat. So y0 hat ni, this part tadi kan, yang cerita tadi, x1 bar minus x2 bar transpose as pull inverse multiply x0. Okay. Mu hat adalah 1 over 2 y1 bar plus y2 bar. What is y1 bar? These two value. Okay. So last sekali you akan dapat this part jugalah sebenarnya. Kalau senang nak ingat, gunakan y0 hat dengan mu hat. Tapi biar usually the formula will be given lah. Okay. Special case if, okay, dikata kat sini, if cos of misclassify, which is C, the value of C is equal. Okay, the ratio is equal. So the cos of misclassification is equal. So this ratio you will get 1 as 1. Okay. And prior probability is equal. Okay, so this part pun you akan dapat 1 kalau dia sama kan. So maksudnya dekat sini dia akan jadi ln 1. This part akan jadi ln 1. Bila ln 1, kalau you kira ln 1 will be 0. Okay, so if the cos dan juga prior probability is equal, so the formula will be like this. Because of this part will be 0, so ia akan jadi macam ni lah. Kita allocate x0 to pi 1 if y0 hat more than or equal to mu hat. Okay, you boleh gantikan mu hat dengan this one, y0 hat dengan this one. Ada yang sama saja. Okay, itu special condition if the cos dan juga probability is equal. Okay, so let's see that example from your textbook actually. In your textbook actually dekat page 584. Okay, kalau example ni dekat page 587. Okay. Alright, so from the example, so dia punya objektif, kalau you baca dekat situ dia ceritakan dia punya case study kat situ. The objective is actually to detect whether the individuals, the newcomers who are hemophilia A carriers or not. Okay, adalah hemophilia carriers ataupun normal person, normal individu. Okay, the blood sample from human known to be carriers and women known to be non-carriers were assessed and measurements were taken on two variable. So kita ada dia punya untuk discriminate dia punya the hemophilia A carriers ni, kita gunakan two variables. Kat sini digunakan x1 log of AHF activity dan juga log of AHF like antigen. Okay, ada dua. So sample size for the normal women, which is non-carriers, is 30, and the carrier from the carrier woman is 22. Okay, so we have two groups here. Okay, suppose that a new patient has measurement. Okay, x1 is negative 0.21 dan juga x2 is negative 0.44. So now we want to know whether this woman will be classified as a normal person or hemophilia A carriers. Okay, so we can use this classification rule to check whether an individual is carrier or not. A woman tadi, a carrier or not. So let's say kat sini, that new patient have AHF activity adalah negative 0.21 dan juga AHF like antigen is negative 0.044. So we have two condition kat sini, whether the cost is equal dan juga the probability is equal, or we have another value of probability. Okay, it depends pada previous study sebenarnya. Okay, depends kalau in real situation, so it depends pada the information yang ada. So kalau tak ada, gunakan the other formula. Okay, let's say kita jawab both of the questions. Okay, the first one, if we have the equal cost and equal probability. Okay, given x1 bar is given, x2 bar is given. So kalau in real study, x1 bar and x2 bar ni adalah information about the variable tadi lah. Kat sini x11, kat sini x12, x21, x22. Okay, from kat sini adalah mean of the variable from the first group, mean of the variable from the second group. Tadi first group adalah apa tadi? First group adalah carrier. Normal person. Okay, from the normal groups, and by itu second group will be the carrier. Okay. So kalau for real study, the value of all of these two mean of the variable we will get from the information ataupun from the previous study. Okay, and here is the information about the S pool. Okay, and then we want to check whether this new patient ataupun newcomers can be classified as the normal person or carrier. Okay, hemophilia A carriers. Okay, so we will use the formula tadi, the rule, the ECM rule tadi. Okay, so first you need to find the Y naught hat tadi kan, Y naught hat. So kat sini dibuat Y hat saja sebab kat sini X kat sini. Okay, X kat sini adalah X1, X2. Kalau kita buat Y naught terus pun boleh, Y naught hat. So you gantikan X1 dengan X2 kat sini dengan yang this one dengan negative 0.210 and negative 0.044. Okay, replace in here. Kita cari Y naught. Okay, so macam mana dapat ni 0.2418 and negative 0.0652? You just minus this with this and this with this, so you will get this matrix. Okay, right. Next kita nak cari M hat. Okay, M hat adalah this formula, so we need to find the Y1 hat and Y2 hat. Okay, so it is, this one adalah, okay, is here. Kan tadi the formula for Y1 bar and Y2 bar. X1 bar minus X2 bar transpose multiply S pool multiply X1 bar. So you akan dapat tadi 37 point something. Okay, so kat sini kalau you tengok, you akan dapat di sini adalah 1 by P, sini P by P, di sini adalah P by 1. Right? So sorry, saya pergi balik. Okay, kat sini. So you akan dapat this part. Okay, kat sini dia buat yang ni sajalah ni. This part adalah tadi X1 bar minus X2 bar transpose multiply S pool. You akan dapat this part multiply dengan X1 bar matrix Last kali you akan dapat 0.88. Sama juga dengan this part. X1 X1 bar minus X2 bar transpose multiply dengan S pool, you akan dapat this part. And ini adalah X2 bar. So, you akan dapat negatif 10.10. So, masukkan dalam formula of M, you akan dapat negatif 461. Okay, tadi kan kita nak comparekan M ni dengan Y0. Kan? Macam like I said tadi, kalau terus you cari Y0 boleh, terus masukkan kat sini negatif 0.210, negatif 0.044, terus you akan dapat the value yang ni sebenarnya, negatif 6.62, dan comparekan Y0 dengan M. Kan? Sebab kita gunakan the second formula tadi, sebab condition dia equal cost and equal P. Jadi kan? So, you akan dapat Y0 adalah negatif 6.62, which is less than the value of M. So, sebab less than kan, so we classify to pi2. Kalau dia more than or equal dengan M, so we classify kepada pi1, the first group. Okay, disebabkan dia less than, so we classify the new observation tadi as second group, which is pi2. Okay, that is the A. Untuk B pula, solution B tadi apa? B tadi soalannya dia kata equal cost with prior P1 is 0.75. The probability for normal person, individu is 0.75, and the probability untuk carrier is 0.25. Okay, we have the value of probability. So, kita gunakan sebenarnya gunakan formula yang sama, cumanya P tadi ada value lah, dia bukan 1. Dia bukan dia punya ratio, probability ratio tadi bukan 1 lah. Okay, so method yang sama, which is kan this part tadi adalah Y0 ni kan, X1 bar minus X2 bar transpose multiply S pool inverse multiply X0 adalah Y0 kan, Y0. This part belakang ni adalah M. Okay, adalah M. Okay, this one lah dia buat sebagai W. Y0 minus M, comparekan dengan tadi ln of the ratio of the cost. Disebabkan cost dia sama, so dekat situ akan 1 multiply pula dengan P2 over P1 kan. So masukkan Y0 hat kat sini, dia akan dapat jawapan yang sama lah, sebab dia dah kira kan, negatif 0.6.62. cumanya kena comparekan dengan this ln of 0.25 over 0.75, which is kalau kira you akan dapat 1.0986. Okay, so Y0 minus dengan M. Okay, Y0 minus dengan M, you akan dapat negative 2.01, which is less than negative 1. So also we classify the newcomers. If we know the nilai probability, we classify the Viewman as the second group, which is the carrier. Okay. Okay, we also can use the Fisher approach to do the classification. We have two method of Fisher approach. Okay, yang pertama ni adalah dipanggil Fisher discriminant function. So actually the formula for the allocation rule using the Fisher discriminant function ni adalah same ataupun equal with the the previous one, which is with equal probability and equal cost. This is the formula. Y naught hat minus mu hat more than or equal to 0. We allocate x naught to pi 1. Okay, and then we allocate x naught to pi 2 if y naught minus mu hat less than 0. Okay, so sama dengan yang tadi lah sebenarnya. This is the first approach. Okay, the first approach sama. Second approach, kita gunakan linear discriminant score, which is you need to find the score of D. Okay, we choose ataupun the group that have the largest D. Okay, we will allocate the newcomers to that group. Okay, so kita kena cari DI for every group. This is the formula. X I bar transpose multiply S pool multiply X, ni adalah newcomers lah, X naught minus half multiply X1 XI transpose multiply S pool inverse multiply XI bar plus ln PI. Okay, so let's say kalau we have two groups, so kita kena cari D1 dan D2. Okay, D1 dan D2. So let's say kalau untuk D1, kalau D1 kat sini, so kat sini will be X1 bar transpose. Kan kalau X1 bar adalah P by 1, kan, the vector. So kalau transpose, you akan dapat 1 by P. S pool will be P by P. X kat sini adalah X naught, maksudnya you, ini adalah P by 1 lah, maksudnya you dia punya vector, kan, you replace the the variable for the new observation. Okay, so kat sini will be P by 1. So bila you multiply this part, you akan dapat 1 by 1 minus half multiply 1 by P multiply P by P multiply P by 1. So kat sini pun you akan dapat the one value 1 by 1 plus dengan ln P1. Kat sini kalau sebab kita cari D1 tadi, kan, so kat sini will be ln P1. Okay, if we do not know the ataupun we don't have the value of probability for the first group and the second group, let's say, so we can assume P is 0.5. Okay, so first of all, to use the second approach kat sini, gunakan linear discriminant score, we need to calculate the D for every group, dan masukkan, replace X dengan X naught, and then we observe which group have the largest D, so we will allocate X naught to that group. Okay, simple as that. Okay, let's say we only have two groups, kan, we only have two group. Macam contoh tadi, kita ada dua, sama ada normal ataupun carrier, non-carrier or carrier of the hemophilia A. Tadi kita ada dua group saja, so we can choose whether kita nak guna the first approach, this approach, ataupun gunakan this approach, linear discriminant score. But if we have more than two groups, ada 3 groups, okay, so kita lagi ataupun memanglah suitable for us to use the second approach. Tak boleh gunakan the first approach. First approach untuk two population ataupun two group sahaja. Okay, the second approach here we can use if the groups is more than 2. Okay, let's see the example. Based on the track records, it was found that the speed for the runner finish 100 meter and 200 meter, okay, which is the two useful variables to discriminate between men and women. Okay, kita nak discriminate sama ada ianya man or woman by these two variable. Dia punya speed dia lari 100 meter dan juga 200 meter. Daripada these two variable, kita boleh tahu this runner are men or women. Okay, assuming that the population covariance are equal, okay, to which group men and women should we classify a runner whose speed for the 100 meter adalah 11 second and for 200 meter adalah 22 second. So kita tahu this runner is man or woman, so we can use the approach of the classification rule tadi to classify whether this runner adalah man or woman runner. Okay, so we classify these two we classify the runner by using the two variable, dia punya speed of 100 meter run dan juga speed of 200 meter run, dia punya masa. Okay, so we try to use both of the feature approach. Okay, given x1 bar and x2 bar, kat sini kita ada 2 by 1, p by 1, which is p is 2, sebab kita ada dua variable tadi untuk discriminate this two groups. Okay, we have x2 bar dan juga we have s pool 2 by 2, which is p by p. Okay, so using the first approach yang tadi lah kan, we allocate x0 2 pi 1 if y not hat, okay, minus mu hat more than or equal to 0. Okay, ataupun y not hat more than or equal to mu hat. Okay, so this part cari y not hat first. Okay, you know how to find this. Okay, this one gantikan x0 ni, replace with the new observation tadi. So you akan dapat y not hat adalah 73.9731. Okay, and then kena cari m. Kena cari m, so you should find y1 bar and y2 bar. Okay, same solution macam tadi juga. So last kali you akan dapat m hat adalah 74.846. Nanti you try buat one by one, you will get the answer. Okay, because of y not hat is less than mu hat. Okay, kalau you kira y not hat minus mu hat, you akan dapat nilai negatif kan, less than 0. So because of that, we classify this new observation to the second group, sebab dia less than kan, the second group, which is men. Okay, that is the first feature approach. Let's see the second approach. Tadi kita nak cari the largest D, so we have to find 2D, D1 dan juga D2. Okay, di sini x1 bar and x1 bar transpose. Okay, from the here. Okay, x1 bar transpose, this part, multiply dengan s pool inverse, multiply dengan x0 here, 1 minus 2, x1 bar inverse, s pool inverse. Okay, x1 bar plus ln of 0.5. So you dapat 371. Okay, do another one for second group. Use the x bar 2 here. Kat sini x0 benda yang sama. Kat sini x bar 2. Di sini x bar 2 transpose. Di sini x bar 2 ln 0.5. Okay, you akan dapat 372. Kenapa kat sini kita gunakan 0.5? Sebab it's not mentioned in the case study tadi about dia punya probability. So we assume it's equal 0.5. Okay, you akan dapat 372 tadi, 371, 372. So we choose the largest D. So we can conclude that the runner can be classified as pi 2, which is the second group, which is men, because of D2 had more than D2, D1 had. Okay, that is the approach, Fisher approach. So usually we will use this approach lah, Fisher approach, to classify the new observation goes to which groups. Okay. Okay, tadi kan I cakap conditionnya adalah covariance sama tadi kan. If the covariance is not equal, we can use this rule which is dipanggil quadratic classification rule. This is the formula. Okay, jarang ditanya, but kalau ditanya, you should know lah. Kita menggunakan quadratic classification rule, and if ada, formula will be given. But usually untuk proceed dengan discriminant analysis, kita akan gunakan we will assume the covariance is equal. Okay, ada dua approach juga. Okay, satu lagi adalah gunakan quadratic discriminant score, the largest one tadi. Cuma formula saja yang berbeza dekat sini. Kita ada sini ln SI. Di sini dia ada absolute value. Okay, alright, that's all.